Okay, this video continues topics in Chapter 5, where we're talking about probability and probability distributions. Chapter 5 is all focused on whole numbers, discrete values, where we're counting things. Chapter 6 changes that, and now we're talking about continuous numbers where we measure something. So we can take on any continuous value and not just whole numbers. And really all we're going to focus on, other than the continuous, we're going to focus on probably one of the most important topics of this class is what the normal probability distribution. So this video will give an overview about the normal probability distribution, and then a follow-up video will show you how to calculate probabilities for the normal distribution using Excel. So a continuous probability distribution means that we have a variable that can take on any value in an interval. So it's continuous, like a car mileage can be decimals, temperature can be a decimals. And because of that, what we do when we calculate probabilities, we're actually calculating areas under a curve. Similar to discrete, a probability always has to be a number greater than 0. And when you'll see this, total area under the curve basically means the possibility of anything possible happening has to sum to 1. And the area under the curve is a probability. We're going to be focusing on the normal probability distribution. This is the function. Don't worry about this, other than it has two constants in it. These are constants, so pi and e. So look at what the other values that we need to know. We need to know what the mean and the standard deviation is. This is a normal distribution. If we look at one of these, that is a normal distribution. It looks like a bell curve. It is a value that's continuous, and it goes infinitely this way, infinitely this way. So it never touches the horizontal line, the x value. It has two parameters that define it, the mean and the standard deviation. The mean tells you where it is on this, this horizontal line. So you can see in this case, the mean of this distribution, 2, is smaller than the mean of mu1 because it's to the left. So these are both normal distributions, but this one, the mean is smaller. The other parameter that defines it is the standard deviation. The standard deviation tells you how wide the distribution is. So if we look at this normal distribution, it has a standard deviation that is much smaller than this one. So how do we determine a probability, which is an area under the curve? So if I look at one of these, the total area under this curve sums to 1. If I add it all up, it sums to 1. So how can I find a probability for this? Exactly. What we do is that we calculate something called a z-score or a z-value. We've already talked about that. And then we go to the back of the book and find the required area under the standard normal curve. I'm going to show you how to do that in the next video. And again, it's always good to draw pictures when you do this. So here's sort of an example. If I want to know what this area is here, this 0.025, how do I find that that's 0.25? Or how do I find this area to the left? So what we'll do is we'll calculate a z-score and go to the back of the book. Remember, the total area equals 1, so this 0.025 plus this 0.975, which is this area plus the area to the left, has to sum to 1. I'll show you how to do this in the next video.